Hi all, I am Jitin K. Kuriakos, working as Assistant Professor in Department of Mechanical Engineering, Jyoti Engineering College. In this video, I am dealing with Magneto Hydrodynamic generation or simply MHD systems. This comes under the sixth module of Sustainable Energy Process. So what is Magneto Hydrodynamic systems? So from the name itself, we can have a basic understanding. The name can be divided into three segments: magneto, then hydro, then dynamic. So dynamic means something is in motion. Hydro means normally it's water but it's fluid. Then magneto means magnetic. So a system where moving fluid under magnetic field. That is what MHD is all about. And the output is actually a DC current, okay, direct current. So an MHD system basically converts the chemical energy of fuel directly into electrical energy. Normally, in conventional methods, for conversion of chemical energy of fuel into electrical energy, we need internal combustion engines, maybe internal combustion engines or maybe gas turbines or something like that. Then that mechanical output should be coupled to an electrical generator. From there we will get electricity. But in magneto hydrodynamic systems, there is no moving parts, nothing is there. The chemical energy will be directly converted as electrical energy. In between, the thermal conversion is there. Okay, that is the basic. So the working principle is actually Lorentz and Faraday's law. In this system, what we utilized is a hot ionized gaseous conductor. This hot ionized gaseous conductor will pass through a magnetic field so that an electricity or a potential is being generated in that conducting fluid. And this generated EM or potential can be extracted towards the outer electrical circuit. So what is the need of hot ionized gaseous conductor? Normally we know the gases are not good conductors. But if a gas is being ionized, then its conductivity increases. So for ionization, one method is to heat the gas to a higher temperature. So that's why we are using hot ionized gaseous conductor here. So I will explain working with a figure. So this is the simplest schematic of operation principle of MHD system. So here we can see we have a duct. Through this duct, the working fluid, hot ionized gaseous conductor, will be passing through this channel, and perpendicular to this motion, we will provide a magnetic flux lines. So what happens as the conductor or the working fluid passes, it will cut the magnetic field. Since it's a conductor, because of the cutting of magnetic field, electricity will be induced in these gases, and that induced electricity, that potential difference, can be trapped by two electrodes. Here you can see an orange watch. One is anode wall and another one is cathode wall. So the electricity can be taken out like this. So here the working fluid is moving in one direction. Perpendicular to that, we are applying a magnetic field, and perpendicular to both these directions, we can extract electricity. So this is the working principle of MHD. So this is another schematic. Here you can see these are the two magnets. So magnetic field lines will be like this, and these blue lines and circles are actually gaseous working fluid, and this external circuit is called through which the electricity is being taken out. So this is the basic working principle. So owing to, towards the more detailed construction side, this can be the arrangement. Actually, this figure is taken from Wikipedia. Here you can see This is the entry point for the hot ionized gaseous conductor, and we are providing a nozzle over here so that its velocity will be increased. For a better performance, velocity should be increased to a higher level, say about 1000 meter per second, so that the efficiency of electricity generation will be better. With the help of nozzle, we are increasing the velocity, and it is allowed to pass through the MHD chamber. So this is the MHD chamber, where we can see these solenoids are actually the sources of magnetic field lines, and these strips are electrodes to extract the generated electrical potential difference. So from the figure you can see that this chamber or MHD generating system is actually a diverging channel. Towards the exit, the cross section will increase. So this is the basic construction of an MHD generator system. Towards the features, the efficiency of MHD converter itself will be in the range of 20 to 25%. So as a standalone system, this is not that much appreciable case, but we can couple this to another conventionally using systems that we will discuss in a later stage. And for a practical MHD converter system, because of this reason, because of the efficiency loss or lower efficiency, a practical MHD system will not run as a standalone system. Okay, it will always be coupled to a secondary system, or maybe the output of MHD will be given to a secondary system, or from a thermal system the output will be given to the MHD. So that will be the normal procedure. And for better working, minimum conductivity required is 10 mho per meter. You know what is resistivity? So resistivity, opposite that resistivity, we have conductivity. So 10 mho per meter should be the conductivity, an ideal case. And the moving conductor will be gas. Then to increase the conductivity, you know, I said gas is not a good conductor. So to increase conductivity, we need to do something. Simply heating to higher temperature will not give you that much increase in conductivity. So first option is to ionization of this, and the second option is to impart a liquid metal. And there is one more thing which is called CD. Okay, potassium and cesium elements can be added to this high temperature gaseous fluid so that its conductivity will increase. And velocity should be 1000 meters per second. That should be the range. Also, the magnetic flux density should be in the range of 2 Tesla. That much high magnetic flux density is required. And towards the types of MHD systems, we have majorly open cycle system and closed cycle system. Then towards the advantages, the on and off time of an MHD system is very less. That is, it can easily be started up and it easily be shut off, because with a fraction of with the seconds or with a fraction of minutes, the MHD system can reach up to its full strength. So it's easy to start up and shut off. And since there is no moving parts in the MHD system, it is more reliable because the chances of failure is less. Okay, and an MHD steam hybrid plant will be providing an efficiency in the range of 50 to 60%. You should remember, in the conventional thermal plants, the efficiency will not be in this range. It will be less. So it's a better option if a hybrid system is utilizing. And it's a direct conversion device. That's why the efficiency is more. We don't have any mechanical energy conversion process in between. That's why it is more efficient. Okay. Then it can produce large amount of power because efficiency is more wonderful. And since the components are less, the overall plant size can be reduced. Okay. And towards the disadvantages, It needs a high pure superconductor to generate a higher magnetic field. Okay, so that is a limitation. Then, since the working temperature is very high, there are chances of degradation of the system. Okay, so the duration of lifetime of these equipments may be lesser. Then the losses of power is very high. We are considering the MHD system alone. Okay, because a large quantity of heat energy is being rejected at the output of MHD generators. Okay, and as I said, because of the high temperature, the corrosion chances and other chances of failures, thermal failures are there. So life expectancy of equipments are short. Then the technical limitations are there for increasing the conductivity of a fluid and also to increase the strength of magnetic field. Also, since production is DC and commercially available electricity or utilized electricity form is AC, then we need DC to AC conversion. Okay, these are the disadvantages. And towards application, it can be utilized in submarines or aircraft for power generation, and domestic applications are also there. Then pulsar detonation rocket engines. So again into space applications and all. Okay, and it can be utilized as a power plant in industries. Okay, for an reliable and uninterrupted power supply. These are the applications. Thank you.